Our role is to help people take the chips that Graham was talking about and the devices Graham was talking about, turn them into real commercial products that have traction in the commercial marketplace. So I'm going to say just a few words about what we can do in terms of product development assistance for people trying to develop products into the conventional energy space. So my talk will be, first of all, just a few words about micro nanotechnology and conventional energy as we see it, based on our practical experience with our customers. And I'm going to echo a lot of what Graham said already. Then I'll talk about a little bit about ACAMP's support for commercialization, how we're going to help people be successful, and then finally a brief summary of my talk. So what is MNT and what can it do for micro nanotechnology, and what can it do for people working in conventional energy? For me, MNT can very simply defined as a device or a process that uses or creates an active structure that is on the micro scale, in other words, sort of micron-sized structures, perhaps up to 100 microns in some cases, or on the nano scale, in other words, well under a micron, perhaps a sub-100 nanometer scale. So we're talking about very, very small things here, which can have some very useful technological functions if we design them correctly and package them correctly. Some examples of products, and really for the conventional energy industry, the biggest demand we see is for sensors, and more sensors. And you can do some really amazing things now with micro sensors that make them very small, very versatile, very easy to deploy into a huge range of situations. So sensors for pressure, temperature sensors for temperature, sensors for acceleration and rotation, accelerometers and gyroscopes. We heard a little bit about that this morning in the drill bit control, but there are many other applications for accelerometers and gyroscopes. I think we'll hear some more in a few minutes about that as well. Lab on a chip devices. We heard a little bit about the ability to do microfluidics. And this is an up-and-coming technology that's finding a lot of traction right now in the medical space, but as somebody pointed out this morning, that it could cross over into the conventional energy space. There are many useful things you can do with microfluidics that could be of benefit, particularly in analysis, and again, a kind of sensor for chemical reactions, gases, or processes you're trying to control. And the other thing that gets a lot of traction at the minute is the nano coatings and nano catalysts. As a centre, we don't really deal with the material stuff like nano coatings and nano catalysts. We focus on the device side of things. The first three groups of things I've listed up there. So some of the areas of application we're actually working with practically with customers interested in commercializing products are things like downwell sensors for doing a whole range of things in logging what's going on at the bottom of a well. Geomatics, the ability to collect and use spatially correlated data. Very useful if you want to monitor the status of a pipeline or something that's going on in a whole oil field. Distributed sensor networks, that's kind of part of the geomatics thing, I guess. And point of use chemical testing. We heard a little bit about the ability to detect oil emulsions in water, and there's certainly some people talking about projects in that area with us at the moment. So what does ACAMP do? Well, ACAMP was founded, driven initially by the fact that there's been a lot of investment in front-end technology research in the Alberta region. We've heard a lot about some of that wonderful technology research early on this morning. Several $1 billion invested in institutes like NINT, National Institute for Nanotechnology, University of Alberta, University of Calgary, University of Lethbridge, and so on. And that investment is starting to pay off. A lot of new IP is being generated, and then people are trying to spin that out into companies. So there are a lot of companies emerging from universities and trying to make their way across the dreaded chasm into the end markets where they can have traction with real end customers. But also some more mature companies, for instance, which have emerged from universities, such as Microline, which has been around for a while now and is actually finding traction in the marketplace. All these companies are facing sort of common challenges in terms of trying to grow and become successful. And some of the challenges we found are some of the newer companies actually are fairly naive commercially and need some help with just learning how to be a business, marketing, defining products, raising finance, engaging with end customers. So that's part of what's needed by these companies. Another part of it is that most micro nanotechnology devices on their own are pretty useless. They're just chips. You can't put them in a real world application. They wouldn't survive. They have to be assembled into a module, often with some electronics to help them function, and then properly packaged so they can survive in the environment you want to put them in, particularly when it comes to the conventional energy industry, where the environments are particularly harsh. So there's a need for the ability to take the output of a university lab or a silicon front-end manufacturer and turn it into a fully packaged and functional product. So ACAMP encompasses all those activities. We have both a strong business development side to our organization, which does all the sort of help with commercialization and business development. But also we have a product development and assembly and packaging organization as well, and that's my part of the organization. Product development to help people use fairly standard product development methodologies to develop robust products, but also assembly and packaging to build the actual devices into real products. So at a glance, ACAMP was established as a not-for-profit corporation, so we don't try to make money on this, we're funded by the government. Established in June 2008 with a funding of $15 million for 5 years, $7 million worth of which was for capital equipment. Clearly we needed to buy some packaging and equipment, and assembly equipment and build clean rooms and so on to actually do the work. And then a further $8 million for operational funding to keep us, pay the people and pay the rent and so on to keep us going for the first 5 years. We've been very fortunate in the last few months to receive a further $2 million of funding from WED for further expansion of our capabilities into laser packaging, and Graham mentioned that briefly before. We're now starting to work on a project to build a packaged laser device for environmental sensing and geomatics, the ability to measure and use spatially correlated data. Our job is to provide a pathway, as I've sort of indicated, to commercialization for micro nanotechnology products, and we provide support in the 3 critical areas we see as critical to commercialization in this particular province, which are marketing and business development, product development, packaging and assembly. And we're trying to help companies bridge that gap between the initial inception of the idea and the final commercial success. So we'll help people get all the way through to commercial sales. That's very much our focus. We try to be easy to work with. We can keep our models for interaction with customers as simple as possible and as clean as possible. We simply charge fee per service. We depreciate our equipment over 5 years, so the customer picks up a share of that depreciation if they use the equipment. Charge our manpower out at cost, and we pass on the cost of any raw materials or external services that we might engage as part of the project directly to the customer. We also like to, because we're funded heavily by Western Canadian funding sources, we offer a very substantial discount to clients operating in Western Canada. So we try to make ourselves attractive that way as well. We try to be flexible. I mean, being commercial guys, we realize that people have lots of different ways they want to work with us. Clients can rent our equipment. They can use our engineering expertise to help them develop new products. We have excellent simulation tools and product development tools. We can even go into very low volume manufacturing for them. We don't claim to be a high volume manufacturer, but we'll certainly get people to the point where they have a few thousand units to get them through to those early market sales. One clear thing we always like to state is that we don't try to take any of the product IP that the client walks in with. They own their own product IP. I think that differentiates ourselves from a lot of other centres of this nature. We do, however, if we do develop new process IP, and we have developed process IP to use on all our equipment, clients are free to use that. We own that. If we jointly develop process IP, we'd also like to own a share of that, because we'd like to be able to redeploy that for other people within the province. Our job is to help as many people as possible, funded by the taxpayer. So then the 2 sides of the house, we have marketing and business development. The business development side carries out all the normal activities that are associated with business development, helping people understand how they're going to get into the market, develop their business case, work with actually external consultants on IP protection if needed, manufacturing strategies, and even going and pitching to customers. We'll cover that whole spectrum of activities needed to get a product off the ground and out to the market. And we also have the ability to do things like some services we provide to customers, such as market research. So we deploy a number of specialists in the different market sectors who have many years' experience in those sectors, and we also have a number of young MBAs who are willing to go out and do the legwork of actually pulling together market data for people so they can figure out, is this the right market for them? Is this the right product for the right market? How best to introduce this product into the market? And so we do all that kind of stuff, and we also help directly with business development. That side of the house is headed up by Ken Brazel, the CEO of ACAMP, who's sitting just down there. And if you want to talk about business development, he's the guy to talk to. I'm the technology guy. This is my side of the house. And we're split roughly 50-50 in terms of numbers as well, because we find that there's a lot of companies need help with business development. So we work more on sort of the conventional product development stuff. So we ideally like to start with a clear specification for the product. We will help clients firm up their specification if needed, and the business development guys have quite a role to play there as well as you go through defining the product. Ideally, we like people to walk in with a prototype, and we can then just figure out how to make that manufacturable, produce it in volume, maybe package and assemble it, and so on. We're very keen on design for manufacturability. These products have to get out to the market. They have to be made at cost and reliably and shipped to customers. So that's an important part of our methodology. Very important for very small products where you have very few. It's very hard to control a lot of the properties of the product directly because you can't even see them, they're so small. We don't do the front-end fabrication at all, as we've pointed out. There are already plenty of facilities in the region capable of doing the silicon fabrication and silicon micromachining and so on. We don't do that, but we do work with assembly and packaging technologies, and we've actually set up a clean room with a bunch of different technologies in it. And we're also very, very keen on making sure the products are thoroughly characterized and understood before they're given to a customer. Again, you can't have give a customer a product that doesn't work. So you need to make sure you really understand your product thoroughly before you hand it over. So we have a lot of emphasis on inline test and characterization, and also end-of-line test and characterization, and product reliability testing. We're expanding those areas substantially to help people really test their products thoroughly before they release them to the customer. And the end product of this process is some robust, reliable products that we believe will be successful in the marketplace.